How does regularization improve regression model performance? Imagine trying to fit a puzzle piece perfectly into a picture. Sometimes the piece is too tight or too loose, and it doesn't match well. That's similar to what happens when a regression model fits data too closely. It might look perfect on the training data but fail on new data. This problem is called overfitting. Regularization helps solve this puzzle problem by making the fit just right. In machine learning, especially in supervised learning, regression algorithms predict continuous values, like house prices or temperatures. These models find the best coefficients or weights to match the data. But if the model is too flexible, it can start capturing noise or random fluctuations in the data. This means it learns details that aren't really part of the true pattern, which hurts its ability to predict new data accurately. Regularization adds a penalty to the model's loss function, which is the measure of how wrong the predictions are. This penalty discourages the model from assigning very large weights to features. Think of it as a gentle nudge to keep the coefficients small and simple. When the coefficients are smaller, the model is less likely to chase after every tiny detail in the training data, which helps it perform better on unseen data. There are two main ways to regularize regression models. One is called L2 regularization, also known as ridge regression. It adds a penalty based on the square of the coefficients. This shrinks all the coefficients toward zero but doesn't make any exactly zero. It helps spread influence evenly across features and reduces the model's variance, making predictions more stable. The other method is called L1 regularization, or Lasso regression. It adds a penalty based on the absolute value of the coefficients. This can shrink some coefficients all the way to zero, effectively removing less important features from the model. This simplifies the model and makes it easier to interpret, especially when dealing with many features. There's also a combined approach called elastic net, which uses both L1 and L2 penalties. It helps select important features while keeping the model stable. This is especially useful when features are correlated or when you want a good balance between simplicity and accuracy. In the world of artificial intelligence and machine learning, regularization is a key tool to prevent models from overfitting. For systems like ChatGPT, DALL-E, or Midjourney, regularization helps ensure they don't just memorize training data but learn patterns that work well on new inputs. This is important for making AI fair and reliable across different situations. In real-world applications, regularization makes regression models more useful in fields like finance, healthcare, and productivity tools. For example, in productivity plugins that predict user behavior or suggest workflows, regularized models stay accurate without overreacting to specific user data. This means better, more consistent recommendations that work for everyone. To sum up, regularization improves regression models by controlling how complex they get. It prevents overfitting, helps models generalize better to new data, and sometimes even simplifies the model by removing unimportant features. This makes the models more reliable and effective in many practical tasks, aligning with the goal of building smarter, fairer artificial intelligence systems.